Hi guys, hope you are going to go over ellipses and parabola today. So just like circle, where it's defined as the equidistance to a single point called the center, and all the way around the circles, that's a set of points, and the equidistance is r. So here, very similar, we have the sum of those distances are the same from two fixed point. We call that the foci. So focus for singular. We have 1, 2 focus, and it will be any point on here. Sum of the distance from f prime to p and f to p is the same no matter where you go. So the graph of ellipse is not a function in Cartesian coordinate because it does not pass the vertical line test. The foci lies on the major axis. So there are two axes, the major and the minor axis. Uh-oh. The pen is not working for some reason. Oh, sorry.
You need to restart?
No. Let me double check. Yeah, my son was in here earlier, so he kind of pulled a cable, but okay, it worked now. All right, so we have the major axis. Now remember that major axis always run through the foci. So here our major axis is along the x-axis, and our minor axis is perpendicular to that. Okay. All right. So let's look at the equation here. So here we kind of derive the equation by finding the distance, right? So basically, the A value is from the center all the way out to the one of the vertex out here. And of course, they are equal distance from the center. Now, all I have to do is basically try to find the distance between them. So the C value is always from the center to the foci, just like our parabola. This is our C value. So the distance x minus c is from, sorry, x is here. X is our distance on the ellipse itself, and that is the coordinate of whatever point that is. So, for example, if you have x is equals to a right here, x minus c is here. Okay, so it's just the difference between those two. So all we have to do is to determine the sum of our distance from any point on this ellipse. And they're trying to prove that the sum of the distance is always equals to a. Right?
Professor, can we go over that one more time, please? I know that x minus c will give me the distance between the focal point and the x. And then it's trying to prove that the sum of the distance is going to give us write in green or any other color what 2a would look like on that ellipsis?
Sure.
Thank you, sir.
Okay, so the distance from here to here is a. This is 2a would be from here to here, all the way across. So basically, it is the distance of the major axis.
Okay, so then a itself is the distance from the center of the ellipsis to one of the foci?
Yes, a is the distance from the center to here and here. Now c is the distance to the foci. This is c.
Okay.
Yeah.
Okay, and then a itself is from one, can I call it a tip? One tip to another?
Sure, yeah.
Okay, I think I get that now.
A is from the center to the tip. So 2a would be from one tip to the other tip.
Okay, one tip to another. Got it. Thank you, sir.
Mm-hmm. Right, so of course they derive all this. and we arrive at here. Okay, but let's look at the conclusion. All right, so this is our conclusion here. So here, the center that we got was 0, 0. It was at the origin. So here we got x squared. X squared over a, y squared over b squared equals 1. Now you see here, these two are a little bit different. Okay? Now, why are they different? Now here we have a is always on the major axis. Okay, so there are two different scenarios. We have an ellipse that looks like this, or we have an ellipse that looks like this. It's elongate vertically or it elongate horizontally. Now, A help us determine which one it is. Okay, so A is always larger than B. Okay, so the larger number determines where the major axis is. So for this example, x squared over a squared, so that means that my major axis runs along the x-axis, and then for this one, the major axis runs along the y-axis, because that's where my foci is going to be. Same thing here. Okay? So again, A is always larger than B.
And Professor, does this hold up in multi-dimensional ellipses?
Yes.
Okay.
A is larger than B. Of course, they have to be larger than 0. Okay. And so here you see the location of it, and you need to memorize this formula. Now, this looks very familiar, right? This is, you think of x squared plus y squared equals r squared. This is very similar to this. Now, let's look at why we have this formula here. And try to understand the formula, because depending on which shape you have, it could be a squared plus b squared equals c squared. It could be c squared equals a squared minus b squared. So there's a lot of different versions of that. So be careful which one that you are dealing with. So let's look at why it's equal to this. So if you want to remember this, A is always the major axis, and this is always the longest one. Okay. Now B and C can be greater than 0, but we know that it's less than A for sure. Okay. But there's no direct relationship whether C is larger or B is larger. We just know it's greater than 0, and they're both less than A. Okay. All right. So here's another way to think of it. Since A is the largest one, that means that B squared plus C squared is equals to A squared. Because if you think about it, when you have x squared plus y squared, these two are the legs, right? This is the hypotenuse. And the hypotenuse is always the largest one. So therefore, if you memorize it with this, it's always going to be true. The two smaller values added together will always equal to the larger value squared. So here, since B and C is less than A, that means that A is by itself. Okay? Whereas Python, I'm used to saying A squared plus B squared is equal to C squared. C is our hypotenuse. Okay? Here, we do not deal with hypotenuse in that way. Here, we are dealing with this. So you take the triangle like so, you do like this. Okay? So this is from here to here, C, here is B. That means that this distance right here has to be A. Okay, and that is the relationship between A, B, and C for an ellipse. Okay. Now, when we get to a hyperbola, you see this again. It's going to be in the normal setting, A squared plus B squared equals C squared. But we'll get to that. Okay. Just know that the two smaller sides equals to the longer side. So you see here, A is along the vertical axis. Remember that A is always the largest one. This time it is along the vertical axis. That's our major axis. It's going to be below the Y. Okay? So very similar to what we have over here. Oh, this is wrong, by the way. This is supposed to be y squared over a squared plus x squared over b squared. For shame.
Oh, okay.
Oh, that's wrong. It's supposed to be swap the other way around. Yeah, please make a note of that.
This is for the minor axis?
No, this is where the major axis is vertical. Over here, the major axis is horizontal. So the larger the number that's below x or y, that tells you where the major axis is. But when we do this, I will use it. Okay? All right, so let's look at this one. So we're going to graph this equation here, give the foci and give the domain range. Okay. So first, we have to get this to equal to 1, because our formula is x squared plus y squared over a squared b squared. So either a or b, the larger value is going to be our major axis. So these two can be interchangeable. Okay, so once we divide by 36, we have the following. I also suggest you rewrite it in terms of 3 squared plus 2 squared, so you know what a and b is. Right? Okay, so now we have a larger number here. So what does that mean?
That means that the major axis lies on the x-axis.
Okay, so I don't want you to say it lie on the x-axis. I want you to say it lie parallel to the x-axis.
Parallel, okay.
Yeah, because now we can this ellipse can go anywhere. The reason why we've been okay that it is the x-axis is because the center is at the origin. Now the center can shift anywhere. So we say parallel to the x-axis or along the x-axis. No, along means on it. Yeah, say parallel to the x-axis. All right, so let's graph this. So we know that, okay, you see that later on, is at the center. Here we know that the a value is equals to 3. The b value is equals to 2. That means we can find out what is the c value. Okay, so we know that a squared is equals to b squared plus c squared, or you can say c squared is equals to a squared minus b squared. Okay, so if you're trying to find c, just plug it in. A squared, which is 9, minus b squared, which is 4, and then we get 5 and then square root of 5. Give us c. So that is the location of my foci. Okay. Now, of course, it's going to be plus or minus because we are moving away from the center, and there are 2 foci. And we know the foci is on the x-axis for this example because our center is at the origin. So let's go. Square root of 5 is about 0.2 something. Let's see what it is exactly. Yeah, 2.23. So 1, 2. So about 2.5. So let's say right here. 1, 2. About right here. All right. So that's my c value, about square root of 5. And if square root of 5. Okay. And let's use the color. And my a value runs along there. So it's at 3. So here and here. And my b value is 2. So 1, 2. Let's say that's 2 right there. And that's 2 right there. So there we have our ellipse. To get the domain range, it's fairly easy. Just find out where the tip of the these points are. So here we have -3 to 3, and this here we have -2 and 2. So that's my domain range. Okay. All right, let's have you. You good?
To summarize, right? Okay, so we look at the original equation, 4x squared plus 9y squared equals 36. We isolated so that it's 1 on the other side, and then you want us to put the denominators in the power of square. So it's x squared over 3 squared, y squared over 2 squared. That allows us to better see what the AB values are. Using those AB values, we found C at plus minus square root of 5. We know for the because the major axis lies parallel to the x-axis, we know that the x value for the points of C are at 0, and then we add plus minus C to find the two foci. So we got 0, root 5, and then 0, negative root 5 as the 2 points of the foci. From there, we know where to plot A.
You said
Oh, yes, sir. So root 5, 0, negative root 5, 0. We add the A's, we add the B's, we draw the ellipses. From there, we can determine domain and range by just looking at the tips of the ellipses, where the domain is, from the leftmost tip to the rightmost tip, and then the range is from the bottommost tip to the topmost tip.
Yep. Okay.
Cool.
And here's a nicer picture. And of course, this is not a function, so we have to break it into 2 in order to graph it, but I'm not going to ask you to graph it using calculator. So, all right, same thing here. Let's see if you can do this one. So go ahead and do it to the side over here. Hi, are you in here? No?
I thought I saw her join the lecture.
On and try to find the those points and the foci, then sketch it.
Is 8.
very good. So in this example here, A would be our 8 and B would be our 4. Very good, because A is always the larger one. And then when you set it up to find C, you get square root of 48, which you even simplify to be 4 square root of 3. Very good. So we have an ellipse that is vertical, where the major axis is vertical. And you posted 4 square root of 3, negative 4 square root of 3 here. And plus and minus 8 and plus and minus 4. Very good. Right, and we got the domain to be negative 4 to 4, negative 8 to 8. And here's a nicer picture. Yes, always try to get a decimal of the square root here, just so you kind of have an idea on how big it actually is, so you can see how close it is to the outside value here.
Okay. So you would prefer me to write out 4 root 3 as positive plus minus 6.928?
No, you would write it out as a root, but you should convert it so that you know where to put that number.
Got it, because you want the scale to be accurate.
Yeah, it's not
Yes,
to scale.
yes, sir.
Okay, so here we're going to ask for an equation by only giving you pieces of information about that. So sometimes a lot of people have trouble with this, especially when we start doing hyperbola. So this is a good practice to start seeing problems like this. So you have to be able to understand how the equation comes together and then how you can construct it using only pieces of information. So first, let's write out all of the given information first. And then you're going to make a sketch so you kind of know where everything falls together. So here we're having center at origin. Okay, so that's easy. Center at origin. The foci is 0 plus or minus 3. So here this will tell you whether you have a major axis on the x or along the y-axis. So 0 plus or minus 3. Draw this better. All right, so 1, 2, 3. That's 1. There's the other one. So I know that's my foci. A major axis length 8 unit. Okay, so a major axis of 8 units give you from here to here. Okay. There you go. So now you can use that to find out what is the B value is. So I'll let you do it.
I'm sorry, Professor, you want me to find the B value?
B value, B as in Bob.
Okay.
So we have our A and we have our C. Now we need our B value so that we can write our equation.
Okay, so using the equation c squared equals a squared minus b squared and plugging in 3 squared for c squared and 4 squared for a squared, I got b squared equals 16 minus 9, or b equals root 7.
Yes. Now let's find out the approximate value of root 7 so we can plot it on our graph. And it's about 2.6. So here we go to 2, a little bit more than 2.5. So somewhere around there. 1, 2, 3. So about a little bit more than half. So now we can kind of sketch our ellipse here. All right. So now we know that a is equals to 4. B is root 7. So that's the only value we need, right? So now we'd have x squared plus y squared is equals to 1. Now the larger value must be along the x, sorry, along the y, because the major axis is on the y. So we need to put the larger number. So if you square this, you get 16. Square this, you get 7. So 7 will go here, 16 will go here, and there's our equation.
So when you want us to find the equation, you don't want the denominators to be in the terms of the square. So you don't want it to be root 7 squared and then 4 squared?
No. The equation there, you should write it like this. I only asked you to rewrite it as 4 square or square root 7 square, only to help you determine A, B, and C.
Okay.
Because a lot of the mistakes comes from people saying, oh, this is the number under here, so A is 7 and B is 16. That's very common.
Okay.
So having you write like this, so that, oh, okay, my A value is this, not this value. You have to do something extra to get the A by taking square root.
Got it.
Okay. So it's just an extra step for you to do. But again, that's just like a mental note. Okay. I've taught this class enough times that I know where the mistakes are. So that's why I'm pointing it out to you. And hopefully you consider it and remember it so you don't make the mistake. But people always do.
Well, I'm sure if they do the test review properly, they'll hear this part of the lecture.
See here, better picture of what I try to draw over there. Another thing I want to point out is this, the major axis of length 8 units. So whenever they give you the major axis length, it is the entire length. It is not from the center to the tip of the ellipse, okay? So the center to the tip is only half of the entire length. Okay, so just want to point that out.
Yeah, so I mean, I actually tried to go with that route first, right? When I saw the major axis length equals 8 units, where I set 8 equals 2a, but I didn't really know where to go from there. So I just went back to the a squared, b squared, c squared equation.
Exactly. All right, so now we talk about center. So nothing new here. We know that H always go with X and K always go with Y. Okay? All right. So again, we're going to do the same thing. Go ahead and sketch this out and then plot points. So plot all foci, plot all 4 of the major and minor axes. Okay, now you're going to draw it on the side somewhere. Go pick a spot to the left of this and sketch it. graph it anywhere?
I'm sorry, were you asking me or mine to graph it?
Oh, I okay, anyway.
Oh, okay.
Well, let's just go with them. Okay, so we see that we have 916 here, so let's rewrite that as 3 squared and 4 squared. So of course, the larger number, a here, is underneath the y. That means that our major axis is going to run vertically. And here, y plus 1, so that means that my k value is -1, and my h value is 2. So that's my center, 2, -1. Look at that. And we just want to graph this, so we don't really have to find out what is our foci are. So we got 4, we got 3 here. So 4 will run vertically. So from the center, go up 4, go down 4. And 3 here means the y-axis, so go left 3 and right 3 from the center. And there you go. Really easy. All right, so here comes the big boy. Here we have something in standard form. I need to put it in graphing form. Now, the book here use standard form as the form that we just look at, but this is the standard form. Standard means that everything is in term like this. Graphing form is what we're doing. Graphing form is x minus h square plus y minus k squared equals 1. Okay. So now we need to put it in graphing form. So we need to complete the square. So go ahead and do work over here.
Yes, sir.
Okay, so it seems that you forgot that we need to factor out the a value first before we try to find it, before we complete the square. Okay, so
Oh, okay.
group all the x's and the y first, then bring the constant to the other side, and then we're going to factor out the coefficient of x and x squared. And so we need to take out the 4, so I'll do that over here. So I need to take out the 4, and then I'm going to have x squared minus 4x. And if I take out 9, I'll have y squared plus 6y. And bring the 61 to the other side, so negative 61. Now I'm going to complete the square by taking half of b and then square it. So half of negative 4 plus negative 4 divided by 2 square. Same thing here. Half of 6 and square. So now I'm going to rewrite this. So I'm going to have negative 4 divided by 2, which is negative 2 square, which is 4. So that's why this is always plus here. Now, I didn't actually just add it 4. Remember that I factored out this 4 right here. So I have to multiply that. So in reality, I'm actually adding 16 to this left side. So that means I need to add 16 to the other side.
Oh, okay.
I'm going to do the same thing for this one. So let me simplify that. Plus 9, y squared minus 6y. 6 divided by 2 is 3. 3 squared is 9. I'm going to multiply with this 9 outside. That's going to give me 81. So I'm going to add 81 to the right-hand side as well. All right, so let's simplify everything here and rewrite this as a perfect squared. The formula for that is x plus half of b. So half of b is negative 2, so x minus 2 squared. Plus 9y half of b here, which is 3 squared. Now here we'd add them all together. So a plus 1 here is 97. We're going to subtract the 61. That gives us 36. Okay? We're not done yet because this is not the correct form. This needs to be a 1, so we need to divide everything by 36. So that finally gives me x minus 2 squared over 9, y minus 3 squared over 6 equals 1. So there my center and is at 2, 3. Okay, 9 here, so 3 squared, 6 here, square of, sorry, it's supposed to be 4. So 2 squared. So that means my a value is 3, my b value is 2. Okay?
Okay.
Yeah.
So I always have to factor out before I complete the squares.
Yes. Because you can see that your final answer, or anytime that you have an equation, this coefficient and this coefficient is always 1. Okay? Okay, so let's look at hyperbola. Okay, a hyperbola is set of all points in plane such that the absolute value of the difference. Okay, absolute value of the difference. So you're gonna subtract two values together, and then take the absolute value of that, which means it's always going to be a positive number. Of the distance from two fixed points is constant. So here's what they're talking about. So we have the two foci. Let's use different color here. This point and this point, the difference from here to here and here to here is always going to be the same number, no matter which point you pick on this hyperbola. So if I pick, so let's say this graph continue this way right here and right here. If I pick this point right here, that means that the distance from here to here, subtract the distance from here to here, is the same value as the distance from here to here, subtract from here to here. It's always going to be the same. Okay?
Oh, okay.
Yeah. All right, so for the figure, the center is at the origin. Again, my HK here is 0, 0. And the foci are at plus or minus C. Now we have axis of symmetry here, just like a parabola running through these two foci. So this is a horizontal axis of symmetry. Okay, so the point V prime to V, go from one vertex to the other vertex, is called the transverse axis. That's basically, think of that as your axis of symmetry. Okay.
And that's from V prime to V, right?
But you can think of it as the axis of symmetry if you extended that to the line.
Okay.
Yeah.
And I'm so sorry. Is V prime and V are the
Vertices.
tips, the vertices of the hyperbola? Okay, I see it now.
Yeah, it's just like a parabola. You have vertex, but here vertices because you have two.
Yes, sir.
Yeah.
How do we have to be aware of the uh, lattice rectum when we're doing hyperbolas in this case to see how wide the parabola is open?
Yes, you can do that as well. Now, the thing about this is that you're not going to get a square because you can see here the foci is not the same thing as a directrix. So this line right here is not the directrix to this hyperbola.
Okay.
So you're not going to have a square. So the lattice rectum right here, I mean, you can use it, but I don't think it's called the lattice rectum for this shape. This one here is a rectangle. And most likely, most of the time, I'm going to say 99% of the time, it's always going to be a rectangle.
Okay.
Okay. Okay. It's a little bit different. Now we see that this changes. Okay. So instead of adding, now we are subtracting. Okay. So if you have two xy, x and y squared are adding, you get an ellipse. But if we subtract, we get a hyperbola. All right, so now let's look at the formula again. A squared plus b squared equals c squared. This is the regular formula that we have. Okay. Now we are adding in asymptotes. The asymptotes are basically the vertex of this rectangle created from the a and the b value. Where is our a and b value? Well, a value is from the center to the vertex. B value is in conjunction with the c value, which is from the center to the foci. Okay. So in all those three comes together. So basically, you can think of this is my c value from here to the center. Because here I have my triangle right here.
Okay.
Okay. And the asymptotes is one corner to the other corner of this rectangle that I create. So when you are trying to draw hyperbolas, you always have to draw this right here, which is the asymptote that the hyperbola will follow. That's why I said earlier, you don't need the lattice rectum because you have these asymptotes to guide you.
Okay.
Okay? Is that clear?
That is clear.
Okay.
So let's say you want us to draw this out for a test, right? What would be the 5 reference points that you would like for this kind of graph, sir? It would be
Okay. So the center, the vertices, the foci, the box,
box. Okay.
the rectangle, and of course the asymptotes. So everything on here. Okay. Now, when we start doing it, you see it's not that big of a deal. It's actually pretty easy to draw these. Okay, so next, let's look at A and B. Look at the location of A and B. Okay, A is always the positive one, below the positive one. Notice that here, X is positive, and the transverse axis, transverse axis is along the X axis. Over here, the Y is positive. That means the transverse axis is along the Y axis. Oh yeah, it says right there. Okay, so please make a note of that. How do you know whether it opens up and down or left and right? Look at the value that is positive.
Okay.
Okay, go ahead and make a note of that if you need to.
So if the value that's positive is X, then it's going to open up left and right. If it's Y, it's going to open up and down.
Yes. Okay, let's move on. All right, so here I'm going to tell you what the equation of the asymptotes is. So I don't really suggest you memorize the equation of the asymptotes. I'll show you how to draw it without dealing with any equations and stuff.
Okay.
All right, so let's try here. Okay, so let's go over it, and so you can see the nice picture here. All right, the A value is always positive under the positive one. So here we have x squared being positive, so we know that's going to open left and right. The A value runs along whatever axis this is. So here this is x, so it's going to run horizontally from the center. So left 5, right 5. Okay. So this here from here to here, that's my A value. My B value here is 7, so that's going to give you my vertical from here to here. That's my B value. So my C value is from the foci, so A squared plus B squared equals C squared. You see here, the foci is laid inside of my hyperbola. So what I mean by inside means here, like this is inside the hyperbola. So since it is on the inside, it means that the C value is the longest value. Okay, but that's why this formula is just like the original formula, the Pythagorean theorem formula. So now we can find out what is our C value. Okay, so we got 74 square root, and let's find a decimal approximation for that. 8.6. Okay, so you see here we have 5, 6, 7, 8.6 right here. Okay, so you can see we have our rectangle that we can create from this. So the rectangle, the A value from the center to the vertex, so you can see here my A value. So this entire thing here, that's 2A. That gives me one of the side of the rectangle. And then double the B value, give me the other side of the rectangle. Okay. So if you go from the center, go up B, down B, left A, right A, will give me, will basically give you the how big the rectangle is. And then we start from one corner, go to the other corner to give me the asymptotes that the hyperbola is going to follow. Okay, so this asymptote right here. And then to sketch it, right?
I'm sorry, please go ahead.
To sketch it, we start from the vertex, and then we move towards the asymptotes. So of course, this asymptote will stretch to infinity. And so what we can do is follow along this path as it gets closer and closer and closer to it. Okay, all right, questions?
So when we're sketching the rectangle, right, we just need to know that one of the sides, the rectangle would be 2A, and the other two sides would be 2B. We don't really have to, for the sketching of the rectangle, we don't really have to care about a C side, right?
No.
Because
C is your
we're just drawing the slant. Yeah, we're just drawing the slant, the line from one corner to another to get that asymptote.
Exactly.
Okay. And then I'm sorry, so I think I missed it. What was the importance of the foci, the C point, being inside the hyperbola?
I was just demonstrating that the C value is larger because the A value is the vertex. So the C value is inside of the hyperbola. That means that the C value is the longest value or largest value.
Okay. Got it.
Yeah, because that will help you memorize this one right here.
Yes, sir.
So the C is the largest one, C's are by. Whereas in the ellipse, the A was the largest one, so the A is.
I understand. And then I think another important thing here is that in the standard form of a hyperbola, x squared over a minus y squared over b, right? It doesn't matter. It doesn't matter whether a is larger than b. It only matters that a is on the positive term.
Exactly. Yes.
Okay.
So A and B here does not matter. It can be A can be larger or B can be larger. It has no yeah, it has no meaning.
Yes,
So
sir.
here, for the formula, you can see you can switch A and B here. It doesn't matter which one is larger. Yeah. Only matter that C is the largest one.
Yes, sir. Okay.
Here they got that on calculator. All right. Let's do a hard one with everything on it. Let's see. On it. Oh, almost. Yeah. Okay. Let's do it. So I'll give you the opportunity to grab this here.
Yes, sir. Professor, in an equation like this, right, do we need to get the coefficients for x and y to also equal 1?
Yes.
Okay.
Now this is a trick. Okay. So I probably should go over this one. So we need the other side to be 1, but we also need the coefficient to be 1. Here's the problem. Now the more important part is we need this side to be 1 first, so we're going to divide both sides by 9 first. So divide this by 9, divide by this by 9, divide this by 9. We get 1 here. So here we have a problem. We have 25 over 9. Okay. Now, there's a reason why I write it like this. Okay. So if you remember, if I take a number or a fraction and divide by another fraction, what do we have? If I have a over b by c over d, that equals to a over b times c reciprocal times d over c. How can I use this fact so that I can rewrite it so that the coefficient of this here, x and y here, would be 1? So let me write this for you. 1 squared over 1 times 25 over 9. Can be rewritten as what?
Y squared over 1 over 9 over 25.
Exactly. So we're going to flip this and put it over on the bottom. So now this and this, you can rewrite it as squares to determine your A and B. So 3 over 5 square and 3 over 2 square. So that's your A value, and that's your B value.
Okay.
Okay. So that's a little trick using algebra. Now we can graph this. We'll find out what the C value is and then plot your foci.
Okay, let's see what I can do. That's horrible. I'm sorry, I got kicked off of whiteboard. 1 second. Slide 28. Okay, well that's.
You ask me?
No. Professor, I have a question for you, right? So we're graphing, but all my values are in different denominators, right? Should I try to find the lowest common denominator in order to make the graph as scaled as possible?
No, just convert to decimal, make your life easy.
Yes, sir. Okay, Professor, this is the best that I can do with the mouse.
Understandable. All right, so let's look at a nice version of it.
Yes, thank you.
Okay, so we got our hyperbola centered at the origin, and we were able to find the b value by rewriting it so that it's in the denominator. So a value is 3/5, and b value is 3/2. And we know that it's, let's see, the y value is is positive, so the transverse axis is going to be up and down. So you see here the parabola, the hyperbola opens up and down. So our values here, you can see that we have 3/5 for the y-axis and negative 3/2 and positive 3/2 for the for the b value. Okay. All right, so now we're going to deal with center being something other than 0, 0. So here we just have to take into consideration what is our h and what is our k. Now remember that h always go with x and k always go with y. Okay, so here we have this equation. We can find out k immediately because we know that h goes with x. So h here is -3, y here is -2. Okay. Sorry, the k value is -2. All right, so our center is at -3, -2. Again, we need to rewrite these two values as 3 squared and 2 squared. So we know that a is equals to 3, b is equals to 2. And now we know that since y is being squared, we know that it's going to open up and down. Okay, and then we can draw our shape here. So the center is going to be -3, -2. A value is from here to the vertex, so this value would be 3. This value would be 3. And then going left and right would be 2. So let's see, a little bit less than that. So 2 here and 2 here. So from there, we can create our rectangle. And then from there, we can draw our vertices. So get my vertices here, the vertices here. That's a pretty rough sketch, but hopefully you get the idea.
I'm sorry, sir. So it seems like on the way that you graphed it that you still use the origin as the center of the rectangle.
So I did this, not for the origin, but maybe I shouldn't have done that. But that's not the origin.
Okay, that's the.
Yeah, I just draw that to help me get the bearing here.
Got it. Okay, so then I know what you mean. I know what you mean.
Yeah, so the center point here would be -3, -2.
Yeah.
Okay.
So isn't there an easier way to do this, right? Like if you know the A and B value, couldn't you just draw a rectangle with an area of 9, and then for some reason, like just draw the asymptotes from that rectangle? It's kind of like what we're doing right now, right?
That's exactly what we're doing. But
Yeah.
you are adding area into that, so that's not true at all. Because if I tell you a rectangle has an area of 9, how many different length and width can you come up with to have an area of 9?
Oh, a lot more than one.
Yeah, infinitely many.
Okay.
So yeah, that don't involve area in this.
So I mean, like, yes, sir, I see what you're trying to say. Is there a cheat code to doing this to make it even faster?
I mean, that was pretty fast. I mean, you only need to know two numbers, right? The A and the B value in the center.
Okay.
I mean,
Yeah,
how much faster do you want?
I see what you mean.
I mean, I can do this in real time. Here, I'll redo this. I'll redraw this completely. Ooh, don't want that. Okay, I'll redraw this again. Once we have the A, B in the center for you. Okay. Let's see how long it will take. Now I'm gonna do it. I mean, I'm gonna do it. I'm not gonna do like skip steps or whatever. So let me draw the. Actually, let's see if I can import a graph here, so I don't have to draw the graph here. Where's all my graph stuff? Here we go. All right. Okay, so -3, -2. So I'm gonna go to -3, -2, make a dot. There you go. Okay, so I know that my y square. That means I'm gonna go up 3, 1, 2, 3. Down 3, 1, 2, 3. And then from the center, I'm gonna go left 2, right 2. That's gonna give me my rectangle. And from here, I can draw my vertices. So it's much easier to draw when you have a graph here. When you have graph paper. So like that. So this one right here. This one right here. And you're pretty much done. So from the vertices here, I'm going to go towards my asymptotes, and those are going to open up and down.
Oh, okay, yeah.
There you go. That's it. I mean, it's just 3 numbers, right? It's no big deal. It takes less than a minute.
And I'm sorry, I may have just completely forgot this, right? But in this case, the vertices is also the C value. It's the foci. No, it's not. It's where we start drawing the parabola out towards the limits of the asymptote.
Mm-hmm.
Okay, I see. Got it. And then the foci itself is encased within the hyperbolas.
Yeah, so it's inside. You can find it by using the formula a squared plus b squared equals c squared. So c is somewhere in here.
Got it. Is there any kind of special characteristics of the foci to a specified point on the parabola line where it equals, you said, the differences between the two legs?
Wait, is there, say that again?
Okay, so let me go to,
Yeah, you can
yeah. So where is your graph?
to the left slide. Zoom out.
Oh, I see. Okay, so I see your graph, but I don't see the pasted Cartesian planes. Okay, I see.
Oh, that's
So
weird.
yeah, what I'm saying is that from the foci here and the foci here, wherever those points may be,
That's
and
really
then
cool about it.
I'm
I think
writing.
yours, I don't think yours is updated. That's
I'm,
probably why you haven't seen it.
I am refreshing right now. Oof, technology. Are you still using that tablet that you recommended earlier, like the Hyon
Yeah,
or Ion one?
yeah.
Yeah.
I don't really suggest this anymore. It pooped on me a couple of times. So, and I
Okay.
don't really use these buttons because they're used for drawing.
Mhm.
So you can adjust like the brush width and then the color and the shades and all that. But I don't use any of that.
Got
So
it.
I don't really. This is too fancy for me.
Too
This was
fancy.
yeah, it's a really big tablet as well. It takes up a lot of room, and there's these buttons I don't ever use. So I think what I need is like half this size. It'd be perfect.
So my
All right, go
question
ahead.
was on this parabola line, if there was
Hyperbola.
some point, hyperbola line, if there was some point on the line, right? Is there some kind of characteristic between the ratio here and the ratio somewhere else?
Somewhere
Is
else,
it,
like where?
how about to the center of the rectangle?
No.
No.
I mean, by definition, it's the difference from the two foci. We have two of those.
Two foci.
Yeah, from here to here,
Mhm.
and from here to here. The distance between the difference between those two is constant, no matter where you pick on the hyperbola.
Got it. Okay.
So the center here basically only helps you with the relationship between the foci and the vertex. So
Got it.
it's symmetrical. So center here gives you symmetry.
Yes,
You
sir.
can fold it in half this way, you can fold it in half this way.
Okay. And as the dimensionality gets more complex, right, the ratio still remains constant between the two foci. The the difference of the absolute numbers or the absolute of the differences.
Yeah, I have a surface. So basically, think of a sheet of paper, and then you fold like this along the shape right here.
Okay.
That's still going to be true if you have. So it'll be a three-dimensional um, distance instead of two-dimensional.
Okay. Cool. All right. Thank you.
Mhm. All right, so we got like one more. Yeah, this one. So write an equation of the hyperbola having center, focus, and vertex. So I always suggest you sketch this out every single time you're given this. Always sketch this out. It does not take you that much, maybe 20 seconds to plot these points. It's going to visually give you an idea of where to go, okay? So center 1, 2. There we go. Focus 6, 2. 2, 4, 6, 2. and vertex 4, 2. All right, so from here, you should automatically know where is your traverse axis. Where?
Should be parallel to the x-axis.
Exactly. Because traverse axis go through the vertex and your foci. So, and the foci and vertex is also equidistant to the center. So now we have to go 3 left to get my other vertex, and then 5 to get my other foci. So that's my foci 1, foci 2, versus 1, versus 2. From there, you can find out what is your B value, and then you can sketch this. It's pretty easy, right? So A squared plus B squared equals C squared. We already know what is A. That's 3. We already know what is C. So that's 2, 4, 5 units away. So this is nothing more than a 3, 4, 5 triangle. So this is a 4. So that means 1, 2, 3, 4. 2, 4. Okay. So we know that B value is 4. I will graph this, right? Okay. So we know that it's going to be x. So x is being square. Oops, this right in the center here. So the center is 1, 2. So x minus 1, y minus 2. We know that it has to equal to 1. On the x, see our a value is 3, and our b value is 4. There you go. Of course, you should write this as 9, 16, but whatever.
Okay.
Right, and there we go. X minus 1 square over 9, y minus 2 square over 16. Are you going to do this one?
Can try, yes, sir.
Go for it. You still there, Aim? All right, looks like we're done.
Hey, Professor, can you check my math really quickly? I think I'm having problem with completing the square on the y term. I know I factored out the -4 on the y term, and then that turns -16y into +4y. And to get the c value, you take b over 2 squared, right? So
Yeah.
4 over 2 is 2 times
Yeah, that's
squared,
right.
so that's 4. Okay, I thought I was just messing that up. And then I would simplify that to be x minus 1 squared, and then y.
Now, before you do that steps, don't forget that you need to add to the other side as well.
Yes,
So
sir.
you
So
need
it's supposed to
to
be plus 9, and then this is going to be plus -16. So,
Good.
I mean, whatever number that would be. Okay, and then
You have a positive 43 here. This is a positive. It's already on the other side.
oh, yes, sir. Thank you.
So again, you get 36 on the other side. Then again, we need to divide each number by 36 to make sure that the other side is 1. And so here we go. This, our A is going to be 2, our B is 3.
Got it. I think the one thing that we need to study or review really well for your test would probably be when you gave us a hint about dividing up fractions. Where was that?
Yeah.
It's all the way up there, because that was a really good hint. That was a really
Yeah,
good
just be
hint.
careful with that.
Okay. Yes, sir. All right. Is there anything else for this week?
That's it.
Thank you, sir. Have a good weekend.
Thank you. You too. Bye-bye.